Okay, so today we're going to be solving systems of equations using substitution. So far we've solved systems by graphing, so you got each of them in slope-intercept form, you graphed them, and then the solution to the system was where the two lines intersected. Okay, but then we saw very quickly that graphing, we're very limited before it starts getting a little bit crazy on the equations that we get. So we're going to learn of another method. If this is your first time seeing substitution, maybe pause the video, write down these steps that we're going to kind of follow here. Make sure you have some paper out and a pen, and you'll be doing some of the problems by yourself. Okay, let's start off with this one. So our first step here, we have a system of linear equations. We have two linear equations here. We're looking for that intersection point. Step one, calm down and pick a variable to isolate. So if we look at the variables we have here, we have four choices. And we're looking for the one that we can kind of get by itself. And when we do this, you look for the variable where like the lead coefficient's 1, don't have to do much like dividing, anything like that. So here, the 5y, well, you'd eventually have to divide everything by 5, so it's not the greatest. Same thing with negative 4x. Same thing with negative 2y. But if you look at this x here, the lead coefficient, the number in front is just 1. So this is going to be our best choice to isolate. Okay. So now I got to get x by itself. Got to get rid of that 2y. So let's add 2y to each side. So we get x equals, 2y's cancel each other out. 10 plus 2y, be careful, they're not like terms. There we go. Okay. What I like to do, these two equations are equivalent to each other, same thing. So what I like to do is kind of cross that guy out. He's down here, usually cross him out, makes it a little bit easier when we get to the farther steps. Okay, so we did step one, calm down. Did step two, we isolated the variable. X is all by itself. Now we're actually going to use the idea of substitution. So we know that these are equal statements here. X equals this. So wherever I see an x, I could replace it with all of this. So if you look up here, you have an x there. So instead of writing x, I'm going to replace it with that guy right there. Okay. So now we get negative 4. I'm going to rewrite that. And instead of x, I'm going to put 10 plus 2y. So I just took x and replaced it with 10 plus 2y. Plus 5y equals negative 20. Okay. Now you can distribute negative 40 minus 8y plus 5y equals negative 22. Okay. Combine some like terms. Negative 40 minus 3y equals negative 22. Add the 40 over to the other side. Negative 3y equals 18. Divide by negative 3. Y equals negative 6. Okay, so we figured out what y is. Now, that's the solving part. We're going to use substitution to find the other variables. So we still have to find x. The beautiful thing about this, we know y is negative 6 for this system here. So you can put in, substitute in y anywhere you see with negative 6 to find x. I think the best equation to use, though, is this guy right here. It tells us what x is when we know what y is. Okay. So x equals 10 plus 2, and instead of y, I'm going to put in a negative 6. So x equals 10 minus 12, x equals negative 2. So now our answer to this system, negative 2 comma negative 6. This, and this is where you should think, what exactly does this mean? Okay? This is the ordered pair that these two lines intersect at. Okay? This is also the ordered pair, the only ordered pair that is going to work for the top equation, and at the same time, it's going to work for the bottom equation. Okay? Okay, so take out your paper, we'll have you work on one, and then we'll go over the solution together. Give me a second to erase all this. Okay. Try this one. Okay, so solve this using substitution, pause the video, try it out yourself, and then come back and we'll go through it. Welcome back. Okay, so when you're picking a variable, the x's, they're kind of ugly. They have negative coefficients on them. This y is not bad. It's a negative y, but you're going to have to divide everything by -1. This y is all by itself. That's good. So I'm going to pick this guy to isolate. So I got to get rid of the -6x, so I'm going to add 6x to each side. So I'm going to have y equals -4 plus 6x. Okay. Remember, they're not like terms, so we can't combine them. So now I can get rid of this. Already used it. Now use the whole idea of substitution. Take this guy and substitute it in for y. So you get -7x. I got to be careful here. You're subtracting. We were subtracting y, but now we're substituting this in there. Don't forget those parentheses. Remember, this is just a fancy way of saying what y is. And that equals -22. Then you do your old pal distributing. It's like you're distributing -1 there. -7x plus 4x. Oops, plus 4. Going crazy. -6x is -22. Combine some like terms. -13x plus 4, -22. Subtract the 4 over. -13x equals -26. Divide by -13. X equals 2. Okay. Now you know what x is. You can use that to find y. Remember, any equation will work, but I think your best bet is the one you already have y solved for. So just take the 2, substitute it in for x. So we get y equals -4 plus 6. And instead of x, I'm going to put a 2. Bam. Then you just solve it. Y equals 8. And then again, write an ordered pair. So think to yourself, Mr. Pons, what does that mean? Remember, that's the ordered pair that these two lines are going to intersect at. Okay? Okay, so that's the bare basics of substitution. Watch some of the later videos for a little bit more challenging problems.